What if our slab has the shape of a lens with double convex sides? Okay, like this one here and this one here. The same is going to happen. Light is going to be refracted twice. However, we have to be more cautious when we consider what the normal is, where the light beam meets the glass or meets the interface. The perpendicular is going to be the radius of that segment of a circle. If I extend this and make a circle out of it, the radius is going to be my perpendicular. So in a point like this, this is where it met the perpendicular. You see our perpendicular here. So instead of going straight, the beam is going to bend towards the perpendicular, towards the normal, since it is moving from a low index of refraction to a higher index of refraction. So in this particular case, because of the actual shape of the lens, it is bending towards what we call the principal axis. Axis of the lens. We call it it is the axis that passes through the middle of the lens. Principal axis of the lens. Okay, now the beam is bending towards the principal axis. It meets the second interface. Then we worry about the new perpendicular. That's here. That's the radius of this other circle at that point. Now, in this case, instead of moving straight, the beam is going to bend away from the normal because we are moving from a high end to a low end. High end of the lens, and outside is the lower end. So bending away from the normal, making the angle bigger, so that's what we get for the beam. So it is moving again closer to the principal axis, towards the principal axis. Now, if I did the same thing from the other side, it's going to bend the opposite way towards the principal axis, making light converge. So if I have two beams like this, that those two parallel light beams are going to converge and focus in a particular point that we call the focal point F. The lens in this case is focusing parallel light beams at the focal point or focus. Just a simple example, we have a beacon in a lighthouse. It produces parallel beams of light. So we have the opposite of what we just talked about. So in this case, we would like light beams to be coming out parallel to each other. So how does this work? The beacon, so it has a bulb and a conversion lens. And the question is, where should the bulb be placed relative to that lens? So if you look at this image here, so what we are looking for is the reverse. We are looking for light coming out parallel like this. So for light to come out parallel like that, so we just have to have the reverse. We need to have our source here, and then light beams coming in like this. They are going to refract to come out parallel to each other on the other side of the lens. So we need to place our light bulb at F.